Good morning friends. In chapter 14 in semiconductor electronics we discuss about the numerical of additional exercise. Now the remaining numericals are 14.11, 12, 13, 14 and 15 we are going to discuss. These numericals are depends on the logic gate, right? The basic logic gates are AND, OR and NOT gate, while the universal logic gates are NAND and NOR gate. Here the different combinations of the gates are given. We have to identify the operation of this given circuit using the logic gate. Now in 14.11 you are given the two circuits as shown in the figure, shows that circuit first act as a OR gate. Here the NOR gate is connected with the NOT gate. That means the output of NOR gate is connected as input of a NOT gate. We have to show that the operation of this circuit is same as the operation of OR gate. Now in B circuit is given. Here the input of two NOT gate are given as input of NOR gate. Again, the output of two NOT gate is given as the input of NOR gate. Now this circuit is act as the AND gate. We have to prove it. Here the two different methods to prove it. One is the truth table and second is the Boolean equation. Boolean equation. Here we apply the method of the truth table to prove that the operation of the first circuit is act as an OR gate and second represent the AND gate. Clear this? Okay. Now for first figure A. In figure A, here we end out. Output of NOR gate is given as the input of NOR gate. Output of NOR gate is given as an input of NOT gate. So that is the NOR gate, that is the NOT. Now here the A and B. Now what should be the Boolean equation of NOR gate? For OR gate, there is the addition or multiplication? Addition, A plus B. And that is also inverted, therefore A plus B bar. A plus B bar. Now what should be the Y? Y is equal to inverted of input. Therefore there is the Y dash, therefore Y dash bar, that is the A plus B. Already there is the Y dash and double bar. That means the A plus B. A plus. Now we prepare the table for this. So A and B are the input. Here the two input are not mentioned. So we consider it this way 0, 0, 1, 1. 0, 1, 0, 1. Right? Okay. Now there is the NOR gate. So first we prepare the truth table for OR gate. OR gate is A plus B. But there is the NOR gate. After that, we prepare the truth table for NOR gate. NOR gate is A plus B bar. And then this input is given to the NOT, again inverted. So output of NOT gate 1 for NOT. So Y is equal to A plus B double bar. A plus B double bar. Okay. Now what is the characteristic of OR gate? 0, 0, 1, 0, 0, 0. Right or not? Again, the characteristic of OR gate is 0, 0, 0. It means if the both inputs are 0, output is 0. So here both inputs are 0, output 0, otherwise 1. So there is the output of OR gate. But here the NOR gate is given. NOR is obtained by connecting the output of OR gate to the NOT gate. Therefore, the inverted of OR gate is the output of NOR gate. Therefore, 0, that means the 1. 1, 0. 1, 0. 1, 0. Or we have the characteristic of NOR gate 0, 0, 1. If the both inputs are 0, output is 1, otherwise 0. Again, the output of a NOR gate is 1 if all inputs are 0. That is the characteristic of NOR gate 0, 0, 1. For OR gate 0, 0, 0. For NOR gate 0, 0, 1. So here both inputs are 0, output is 1. Otherwise 0. So this output of a NOR gate is given as the input of a NOT gate. Again, that is the inverted. Therefore, 0, 0 convert into 1, again 1, again 1. So now see there. These two columns are same. Thus, this combination of the gates act as an OR gate. Thus, from truth table, such circuit act as an OR gate. And also here we prove that the Boolean equation of the NOR gate is y dash is a plus b bar. That is given as the input of the NOR gate, again inverted. Therefore, y is equal to y dash bar. Y dash is a plus b bar. Therefore, a plus b bar and bar. So double bar, that is the cancel. Therefore, a plus b. That is the final output of this circuit. So that acts as an OR gate. That is act as an OR gate. So that is the truth table for figure A. Now for figure B. Figure B, what is given? The output of two NOT gate is given as the input of a NOR gate. So here A, that is the A bar, that is the B, that is the B bar. Now what should be the final output of NOR gate? Final output of a NOR gate, y is equal to A bar plus B bar and also bar. Also bar. Due to this bar, here the operator is changed. Operator is changed. Therefore, we can act like this way. That is act as A double bar dot B double bar. Therefore, that is the A dot B. That means that is act as an AND gate. That is act as an AND gate. So we are preparing the truth table. Before this, here in figure B, the output of both NOT gate is given as the input of a NOR gate. In figure B, output of both NOT gate is given as input of NOR gate. So what should be the truth table for this? First thing A, B. Therefore we prepare the truth table like this way, A and B. Output of the first NOT gate, that is the A bar. That is the A bar. And output of the second NOT gate, that is the B bar. And final output of NOR gate is Y is equal to A bar plus B bar and whole bar. That is for NOR gate, that is the NOT gate, and that is also the NOT gate. Now here the two inputs are given without mention. That means the value are given. We consider 0, 0, 1, 1. 0, 1, 0, 1. So what is the output of first NOT gate? A is the input, output is A bar. Therefore, what is the A given? That is the inverted 0, 1, 0, 1, 1, 0, 1, 0. The same manner, the output of second NOT gate, B is the input, output is B bar, that means the inverted of B. 0 is given, 1. 1 is given, 0. 0 given, 1. 1, 0. Now, that is the NOR gate. NOR gate has the characteristic is that if the both inputs are 0, output is 1. Because the characteristic is 0, 0, 1 for the NOR gate. If the both inputs are 0, output is 1, otherwise 0. Both inputs are 0 here. Both inputs are 0 here. Therefore, there is 1. Otherwise, 0. Only for the last combination here, the both inputs are 0, therefore the output is 1 for the NOR gate. Okay, now forget these two. Compare to the original input and output, final output. Now here we obtain the one only for the both inputs are 1. That is the characteristic of AND gate. 1, 1, 1. Now result from this truth table, the final output is according to the both original input or the initial input, A and B. Here the characteristic of AND gate is, here we obtain the different output is 1, final. Therefore 1 is obtained for which condition? Both inputs are 1. That means the 1, 1, 1. That is the characteristic of AND gate. So from truth table, such circuit act as AND gate. Clear this? So very easy if we keep in mind the characteristic of AND and OR gate, and also NOR and NAND gate. Now next, in 14.2. Write the truth table for the NAND gate connected as shown in the figure. Hence, identify the exact logic operation carried out by this circuit. Now listen, here the both inputs of a NAND gate is short circuit, that means the combined. So as a result, this gate acts as a single input, single output. So only we have the one gate, it has the single input, single output. So that is the NOT gate. So this gate acts as a NOT gate. Right? Now here, both inputs are short circuited. So it has single input, single output. So it acts as NOT gate. NOT gate. So here the both A are given. AND gate has the characteristic, that is the Y is equal to A dot B bar. Y is equal to A dot B. AND gate A dot B and bar. But the both are same. Both are same, A and B. So it's equal to A bar, A dot A bar. That means that. So what is the equation? For that purpose, what is the truth table? We prepare the truth table like this manner. A, B. After that, the Y is equal to A dot B, and final is the A dot B bar. That is the A. B is equal to A. Now, output of AND gate Y is equal to A dot B. And for the NAND gate, Y is equal to A dot B bar. Here the two inputs A and B, but the both are same. So when the A is equal to 0, B is also 0. A is equal to 1, B is also 1. And if the A is equal to 1, both inputs are same, therefore B is also 1. Yeah, what is the characteristic of AND gate? If the both inputs are 1, at that time the output is 1, otherwise 0. 0, 0, 0. That is the one. Now the NAND gate, output of a AND gate is given as input of a NOT gate. That means the AND plus NOT. So in NAND gate, the input is inverted 0, 1, 1, 0. 0, 1, 1, 0. So now consider the initial input and final output. Input is 0, output is 1. Input is 1, output is 0. So as a result, this circuit is act as a NOT gate. This circuit is act as a NOT gate. Clear this? Okay. Now next 14.13. First we consider the figure A and then figure B. Now here the NAND gate is given, that is the similar to the 14.11. 14.11. How? Already we discussed in 14.12, if the both input of the NAND gate are short circuit, so it acts as a NOT gate. So here there is the first NAND gate, there is the second NAND gate. For second NAND gate, both inputs are connected with each other. Both inputs are connected with each other, therefore it acts as a NOT gate. Therefore, a circuit becomes like this way. That is our NAND gate. Output of this NAND gate is given to the NOT gate. So there is the NOT, and there is the Y, and there is the Y dash. Here the input is A, that is the B, that is the NAND gate. So here NAND gate Y dash is equal to A dot B bar. So that is the A dot B bar. A dot B bar. Right? Okay. Now here there is again inverted. Therefore A dot B bar whole bar. Therefore there is act as A plus B. A plus. Now we check it from the truth table. So we prepare the truth table for given operation. First thing, here both inputs of second NAND gate are short circuited. So it acts as NOT gate. Therefore, the truth table so first the A is the input, B is also input, while the output of AND gate, there is the A dot B. First we write down the output of AND gate. After that, for NAND gate, the Boolean equation is Y dash is equal to A dot B bar. And this output is given as the input of a NOT gate. Therefore, final output of a NOT gate Y is equal to A dot B bar and also bar. So with help of a truth table, we are going to prove that the logic operation carried out by these two circuits are. So for first, here the two inputs of this circuit. So we consider the inputs are 0, 0, 1, 1, 0, 1, 0, 1. Now for the AND gate. What is the characteristic of AND gate? AND gate has the characteristic is that if the both inputs are 1, output is 1. If the both inputs are 1, output is 1. Otherwise, that is 0. Otherwise, that is 0. Now here there is the 0, 0, therefore 0. 0, 1, 0. 1, 0, 0. 1, 1, 1. Now for NAND gate. NAND gate is prepared by the output of the AND gate is given to the input of a NOT gate. Therefore, what is the output of AND gate? That is the inverted. Therefore, 1, 1, 1, 0. That is the output of NAND gate. And also from the characteristic of NAND gate 0, 0, 1. If the both inputs are 0, output is 1. Otherwise, if the both inputs are 0, output is 1. Again, the AND gate has the characteristic is 1, 1, 1. And characteristic of NAND gate is 1, 1, 0. If the both inputs are 1, at that time 0, otherwise 1. Again, if the both inputs are 0, 1, output is 0, otherwise 1. Now, this output of NAND gate is given as the input of a NOT gate. Therefore, again, there is the inverted. Therefore, 1 is inverted into the 0, 1 is inverted into the 0. Again, the 1 is inverted into the 0, and this 0 is inverted into the 1. So, from initial input and final output. So, we can say that here the different output is 1 only for the both inputs are 1. Therefore, this combination is act as the AND gate. That is the characteristic of AND gate. So, this combination or this circuit act as AND gate. From the final output and initial input, here 0, 0, 0, 0, 1, 0, 1, 0, 0. And if the both inputs are 1, we get the output is 1. So that is the characteristic of AND gate. So this combination is act as an AND gate. Clear it? Okay. Now listen in figure B of numerical 14.30. Now here the three NAND gates are connected and shown in the figure. The first NAND gate has the both inputs are short circuit. The same manner, the second NAND gate has the both inputs are short circuited, and that is also the third NAND gate. That means the first two NAND gate act as a NOT gate. Act as a NOT gate. So equivalent circuit of this figure is like this manner. Here there is the NOT gate. There is also second NOT gate, and the output of both NOT gate is given as the input of a NAND gate. Input of a NAND gate. So equivalent circuit is like this. There is the A, there is the B, therefore A bar, there is the B bar. We have to also identify the operation of this logic circuit. For that purpose, we are going to prepare the truth table for this circuit. For that purpose, here these are the inputs A, B, and also the output, and different here the two inputs, therefore different four combination of the input take place. Now for first A is the input and B is also input. So here we can consider the combination of the inputs 0, 0, 1, 1. B as 0, 1, 0, 1. Now what is the output of first NOT gate? That is the A bar. That is the A bar. And output of second NOT gate is B bar. That means the second NAND gate. So here there is the inverted 1, there is the 1, there is the 0, 0. Now output of second NOT gate and NAND gate, that is the NOT, therefore 1, 0, 1, 0. Now this A bar and B bar is given as the input of a NAND gate. Now Boolean equation of the NAND gate y is equal to A bar dot B bar whole bar. Right? Okay. And what is the characteristic of NAND gate? There is the characteristic of AND gate is 1, 1, 1, while for the NAND gate 1, 1, 0. If the both inputs are 1, then output is 0, otherwise 1. Therefore 1, 0, otherwise 1. If the both inputs are 1, output is 0, otherwise 1. That is the characteristic of the NAND gate. Therefore A bar dot B bar whole bar. So that is act as the OR gate. So as we compare this output with the original input, here we obtain the different output 0 if both inputs are 0, otherwise 1. That means this combination is act as a OR gate. This combination is act as a OR gate. Or this circuit act as OR gate. Act as OR gate. Right? Because here the different output is 0 is obtained if the both inputs are 0. That is the characteristic of OR gate. Otherwise 1. So final output is 0, 1, 1 and corresponding to this input. So different output is 0 for both inputs are 0. That is the characteristic of OR gate. Therefore, circuit given in figure B is act as a OR gate. Clear this? Okay. After that here 14.40. Write the truth table for the circuit given in the figure below consisting of the lower gates and identify the logic operation carried out by the circuit. Now here there is the first lower gate and that is the second lower gate. For second lower gate, both inputs are short-circuited, therefore it acts as a NOT gate. It acts as a lower gate. For lower 2 gate, both inputs are short-circuited. Short circuit. So it acts as a NOT gate. It acts as a NOT gate. Therefore, our circuit becomes like this way. There is the OR gate. Input output of this OR gate, NOR gate is given as an input of a NOR gate. So there is a final one. That is the input A and B. That is the input A and B. So here there is the y dash. Y dash is equal to Null Gate. Therefore A plus B bar. A plus B bar. And that is again inverted. Therefore A plus B double bar. A plus B double bar. So it is act as an OR gate only. A plus B. A plus B. How we prove? With help of the truth table. For that purpose here, we prepare the truth table like this manner. So here the two inputs, therefore 4 different combinations must be supplied. And we prepare the truth table for first the OR gate, then Null Gate, and then the final output of a Null Gate. Final output of a Null Gate. So that is our input A and input B. Input A, input B. Here the different combination of the 4 inputs 0, 0, 1, 1. Now the B is considered as 0, 1, 0, 1. Now here, first output of a OR gate. Output of OR gate is A plus B. A plus B. What is the characteristic of OR gate? OR gate is, the gate is, if the both inputs are 0, output is 0. Both inputs are 0, output is 0, otherwise 1. But there is a Null Gate, therefore for Null Gate, there is the inverted y dash is equal to A plus B bar. So inverted of output of Null Gate, therefore 1, 0, 0, 0. This output of Null Gate is given to the input of a Null Gate. For Null Gate. Final y is equal to A plus B already bar, whole bar, that is the A plus B only. So inverted of this output of Null Gate, again 0, 1, 1, 1. So this column is combined or the compare with output of a OR gate. So hence there is proof that this combination is act as an OR gate. This combination is act as an OR gate. It act as OR gate. It act as an OR gate. Right? Okay. Now after that the 14.15. Write the truth table for the circuit given in figure consisting of the Null gates only. Now identify the logic operation performed by the two circuits. First circuit is this, second is this. For A, there is the Null gate, both inputs are short circuited. So it acts as a only Null gate. It acts as a only Null gate. There is also A and A. Right? Therefore, output is A plus B bar. A plus B bar. That means the A plus A bar. That means only A bar. Only A bar. So we have to prepare the truth table. So in figure A, both inputs of Null gate are short circuited. So it acts as only Null gate. Only Null gate. Now we prepare the truth table for this circuit. Therefore, inputs A, B is same as the if the A is 1, so B is also 1. If the A is 0, B is also 0. Both are same. Now, lower gate has the characteristic. First we have for the lower gate, and then for the lower gate. Right? Lower gate has the characteristic is if the both inputs are 0, output is 0, otherwise 1. While the lower gate has the characteristic is output is 1 if both inputs are 0, that means the 0, 0, 1. Therefore 0, 0, therefore 1. Otherwise 0. So here original input is for A 1, output is 0. That is the 0, that means the 1. So it acts as a NOT gate. It acts as a NOT gate. Now after that the last, that is the figure B. Here the three lower gates are given. Lower gate 1, that is the lower gate 2, and that is the lower gate 3. Now listen, for lower gate 1 and 2, both inputs are short-circuited. Therefore it acts as a NOT gate. Like this manner. Right? Therefore A is given, is converted to A bar. B given, that is converted to the B bar. And that is the lower gate. Therefore Y is equal to A bar plus B bar whole bar. So that is act as an AND gate. A dot B. That is act as an AND gate. We have to prove with help of a truth table. For that purpose, we are going to prepare the truth table. So for truth table, we write down this manner A, B, and this. Here the two inputs are given, therefore 4 different combinations of the inputs we have to do A, B. And first lower gate act as a first and second lower gate act as a NOT gate. Therefore we also have to write down the A bar, B bar. And this input is given as the input of a third lower gate. Therefore we prepare the truth table for this type of the combination, this way. There is the A and B are the inputs initially. So here the different combination of the inputs are 0, 0, 1, 1, 0, 1, 0, 1. Now due to the first lower gate having the both inputs are short-circuited, that act as a NOT gate, therefore diaphragm's output is A bar. And second has also the B bar. So there is the inverted A 1, 1, 0, 0. B also invert 0, 1, 0, 1, 0. This combination ADS and BDS is given to the lower gate. Lower gate has the characteristic if both inputs are 0, output is 1. Both inputs are 0, output is 1. Otherwise 0. That is the output of a lower gate, final lower gate field. Clear? Oh. Now listen. Here the different output of this lower gate is this one. This one is obtained for which input? Both inputs are 1. So that is the characteristic of AND gate. If the both inputs are 1, output is 1. Thus, above circuit is act as AND gate. There is, so this circuit is act as an AND gate. So using the logic gates, So we can easily calculate the numerical or the logical operation of the given combination of the gates. So here this chapter with the numerical is completed. Clear? Okay.